Hi, welcome back again to my channel. Again on this video we're gonna discuss an excellent problem from Katrina Shearer. Okay, so as usual, before we discuss the problem together, I would suggest that you give it a try, the problem by yourself first. So please pause the video for a moment and give it a try. Alright, let's get started. Okay, so we will divide the hexagon into several regions. So like we cut one, like we use this dashed line, two dashed lines, like to cut into several regions. And also notice, let's say that we call this as A. Okay, so the first triangle is A, the second triangle is B, and the third one is C. Okay, so notice if we reflect the region A, we reflect to the line, let's say XY. What do we get? So we reflect the region A into the line XY. So this point will goes to that point, this point will goes to this point, and that point will goes to that point. So it means the blue triangle is also the A triangle. Right. Next, remember that if we have a hexagon, okay, since the internal angle of a hexagon is 120 degrees, so this must be 60 degrees, and similarly this must be 60 degrees. Okay, and therefore this must be also 60 degrees as well. Therefore we have an equilateral triangle. So if we call the side of the hexagon to be A, then therefore the length of this triangle is an equilateral triangle of sides A, right? Okay, and since this line is parallel to that line, this is also 60 degrees, and that one is also 60 degrees. So then we have a bigger equilateral triangle of length A plus half of A, so 3/2A. Therefore this one is also 3/2A. Okay, now notice what is the comparison between the area of C and the area of A. Okay, so the triangle C, we can consider triangle C as a triangle of base 3/2 of A, and the height is T, this one, for example. Okay, and similarly the triangle A can be considered as a triangle of base half of A, since this is A, right? And the height is also T as well. So since the proportion of the base between the smaller and the bigger, I mean the triangle A and the triangle C, is 1/2 to 3/2. So therefore the area of triangle A is 1/3 of triangle C, right? Okay, so that's what we know for the moment. So let's look at another thing. So Notice that the segment XY is parallel to that one, and this one is also parallel to that one. So therefore, this segment is of the same length as XY, right? And also have the same height. So the area of this is also B. So that's congruent to the triangle B. Now look at to this side. So this triangle, let's call it D at the moment. Okay. Triangle D and triangle B share XY as their basis, right? So triangle D can be considered as, or let's look at it in this way. So we have a parallelogram. So this one is parallel to that one, and this line parallel to that line, to this segment. And then this XY is the diagonal. So D is half of the parallelogram, which means that the area of D is exactly the same as the area of B. Okay, so what else that we don't know yet? So how about this one? Okay, so notice by similar triangle, this triangle is similar to that triangle. Since the proportion of the smaller triangle compared to bigger triangle, so remember that the side of the leg, this leg is half of A, right? And the leg of the bigger triangle is A. Okay, which means that this one compared to that one is in the proportion 1 to 2, right? So then this triangle E, let's say for the moment, is a triangle that having the base twice as the base of the triangle A, right? So if we call whatever the base of the triangle A, let's consider this as the base of triangle A, right? So this guy is twice of that guy, and the height of triangle A is exactly the same as the height of the triangle E. Why is that? So what is the height? This one, right? Which is that one, which is the same as this one. Okay, so triangle A and triangle E have the same heights. Meanwhile, the triangle E having base twice as much as the base of triangle A. So then this triangle E is twice of A. Okay, how about the one that we put question mark on it, this one? Okay, by using similar triangle again, this height will be the same as that height, or you can also use trigonometry, for example, because this angle is the same as that angle, and this side is the same as that side. So this height is the same as that height, and this triangle is having the same base as triangle A and having the same height as well as triangle A. So this is also equals, the area is also equal to A. Okay, so this is A as well. So what remains is this one and this one, right? Okay, so how about this? Let's call it F for a moment. So we can think of F as triangle with the base xz, right? So F consider F as a triangle with base XZ, but XZ is also the base of triangle C. Okay. Now, what is the comparison between the height of C and the height of F? Now, if we take a perpendicular line like this, by using similarity or by using trigonometry, we can see that this length, which is T, is the same as that one. Why is that? Because this angle is the same as that angle, and that side is half of A, which is the same as this side, which is half of A. So it means that F is a triangle having the same base as triangle C and also having the same height as triangle C. Therefore, the area of F is the same as the area of C. Okay. Now, we have only one more region, right? What is this triangle? Let's call it G, for example. Okay. Triangle G is having the base half of A as well, similar to the blue triangle. And the height is the same as the height of the blue triangle, right? So G is exactly equal to A. Okay, so now we can compute the total area of the hexagon, right? So there are 3 B's, which is this one, that one, and that one. And there are 2 C's, okay, and there are 2, 3, 4, 5, 6A. Okay, but C is exactly 3A, right, from this connection, that the area of A is 1/3 of the area of C. So the area of C is 3A. So this can be written as 3B plus 2C plus 3A plus 3A. And we can replace this 3A by C. So we have then 3B plus 2C plus C plus 3A, which is 3 times A plus B plus C. Okay, so the shaded region is, the area of the shaded region is A plus B plus C, and the total area of the hexagon is 3 times of the shaded region. So therefore, the shaded region is 1/3 of the whole hexagon. So that's it. So if at the first time you manage to solve this by using calculation, that would be fine. So at the beginning, when I did this problem, I solved it also with heavy calculation, but then I end up with the answer of 1/3, and then that makes me suspicious. So I try to find another way how to dissect the hexagon so we can easily see that the area of the hexagon is exactly 3 times the area of the shaded region. So that's all. Thank you very much for watching. See you again on the next video. Bye bye for now.